Great. Hi, everybody. Thank you so much again for the awesome introduction. The name of my talk is Pipelines, the Dangerous Beauty of Go. And I just want to introduce myself very briefly. So, like Evgen said, my name is Anna Rosenthal. I'm a backend engineer living and working in New York. Here's my Twitter handle. If you ever want to me, my DMs are open. I'll be happy to hear any feedback from you. And like I also mentioned previously, here are all the technologies I worked with. And more recently, actually, I've worked with a lot of Google products, some of them being Go, GCP, and GKE. A few fun facts about me too. Um, you're probably asking yourself, what is a developer from New York doing at Deadlock? And the fun fact is that I actually grew up in Germany, and I was in Berlin last fall when I submitted this talk. So I just want to say a huge thank you to DevFast crew for accepting my talk. And while I'm fluent in German and Russian, I could not give today's talk in either language, so you're stuck with my English. And outside of work, as you can tell in this picture, you can probably guess, I'm very passionate about recycling, public transportation, libraries, and gender equality. I like classical music, Dutch bikes, and German bread. Without further ado, though, um, I want to give a quick intro who this talk is for and why I chose to talk about this topic. So my talk in general is for Golang beginners. Ideally, I would love for you to be familiar with types, slices, functions, and maybe even anonymous functions. But if you're not, it's okay. I'll do my best to explain it and hope you're smart enough to pick it up on the fly. And since this is a talk about a concurrency pattern, it's hard to talk about concurrency in Go, not explaining how concurrency in Go works. So I'll introduce very general concepts like processes, threads, concurrency versus parallelism, and I will also go into very specific Golang implementations of concurrency and how it's being achieved in Golang. And this is how we're going to do it. First, we will talk about threads, then Goroutines, channels, and then we will go over an example, a very simplified example of pipelines. I do want to highlight the fact that I will not go into testing of pipelines, and I will also not go as much into error handling. I will mention, though, the danger of it, and here's the dangerous part of it. But that's a whole nother talk in of itself. I just want to introduce this pattern to somebody who is probably starting out with Go and is curious as to what is the power of this language. And a Go pipeline is something I implemented in my previous job about a year ago when we were trying to process high batches of actually BigQuery tables and write out new BigQuery tables. And I found this pattern very helpful and very performant and powerful when it came to batch processing of data. So at a minimum, I would like for you to get some understanding of how concurrency in Go works. So you know some um, terms and you can have a conversation about it. At least you'll get curious about them. And at a maximum, I'd love for you to get an understanding of a pipeline pattern and ideally play around and try it for yourself. I will be putting up the slides later on probably my Twitter, or you can also just tweet me and I'd be happy to share them with you. So let's actually go back to very basics and let's discuss what a thread is. So as you can probably know, our computers can do a lot of things. I can be talking to you, I can be sharing the screen. I also have a calendar app running in the background. And that is because our operating systems can run multiple programs at the same time. This is being possible thanks to processes. So process is something that executes a given program. While it's the number, this is the overarching idea of doing multiple things at the same time, the cool thing about operating systems is that they can also run subtasks within processes, and those are called threads. So you can think of a thread as a slice of a process itself. Every process triggers at least one thread at a startup, and that's called a main thread. And then according to the needs of the program, all the programmer's needs, additional threads may be spun up, and they can also be terminated given the resources. And multi-threading is this like big concept that people like to talk about, and it's an idea of running multiple threads within a single process. And if you're curious about what that looks like, a quick thing for you to test it out for yourself is to look for Activity Monitor on your laptop. And if you see at the very bottom, it actually lists all the processes and all the threads. And if there's one thing you're going to remember from the slide is that the count of threads is always higher than the count of processes. And they all have a unique IDs. And then again, if we look at the bigger picture, here's an operating system. It has a lot of processes, and each of them will house their own threads. I do want to briefly mention how memory is being managed in this case. So each process has its own chunk of memory assigned by its operating system. And by default, that memory cannot be shared with other processes. So my browser, for example, has no access to the memory that's being assigned to my Spotify app, and vice versa. And the same thing actually happens if we run two instances of the same process. That is, if I have multiple windows of Chrome or Safari, and the operating system treats each instance as a new process, and it dedicates its separate portion of memory to them. And by default, two or more processes have no way to share data. However, the cool thing about threads is that they can actually share a memory. So threads share the same memory assigned by the parent process, and data, for example, in my Spotify main interface can be easily accessed by my playlist or by the by showing me the picture of an artist or queuing up the next song. Therefore, it's much easier for two threads to talk to each other, and they're usually much more easy to manage from operating system standpoint. They're lighter than a process, they take less resources, and are faster to create. And you probably, I don't know if you're asking yourself, but you might want to ask, why would a process employ multiple threads? And that's the idea of doing things in parallel, and that's because doing so makes it so much faster for us to accomplish things. Now, I want to briefly introduce the concept of concurrency here. And it kind of goes along the concept of structuring program in such a way that it breaks in the program into pieces, and those pieces can be executed independently. There are a few things that kind of like get dangerous if we don't do it right. Some of them are race conditions. There's also deadlocks. And if threads don't finish in the same order that they were initiated, by design they're asynchronous, we may get some memory leaks. And it's important to remember that each thread initiates and finishes at its own pace without regard to other threads. So because they don't really know what other threads are doing, things may get dangerous. And just like to briefly mention, the most common form of race condition, that's when multiple threads try to access the same piece of memory at the same time. And the problem with this scenario is that many operations can be ignored, or worse, our memory can get corrupted. A quick plug for a really awesome tech talk by Rob Bike, which some of you might have heard. If not, I highly recommend you check it out. I don't want to steal his thunder. He has a great talk about concurrency versus parallelism. And to give you just like a very basic, maybe very brief takeaway for me, is just concurrency is dealing with lots and parallelism is doing lots. The two concepts may sound very similar, but I would encourage you to understand what the differences are. And I will just briefly mention one more thing, is that concurrency means that the application has more than one thing to do at the same time. And it's about creating multiple processes executing independently, while parallelism is about running pieces simultaneously. And here comes the time for actually discussing how concurrency, not parallelism, is achieved in Go. There are three, mainly there are two things, but we'll actually like add one more thing that I'll show to you for the context of a Go pipeline, but very fundamentally in Golang, they're achieved with the help of Goroutines and channels. So if you remember the time when I explained to you what threads are, Goroutines are lightweight threads. They're a wrapper on top of threads, and they're managed by Go runtime rather than the operating system. Goroutine and of itself is much like a thread. It accomplishes multiple tasks and it's extremely cheap. They're multiplexed to fewer number of OS threads. So there could be one thread and it will have thousands of Goroutines. If we compare Goroutines to threads, they have a faster startup time. They can communicate with other routines with lower latency, and they're independent from hardware. And of course, how would it be not a tech talk without me showing you some code? Here's an example of Goroutine, and I want to briefly explain what makes a Goroutine. So if you first look at the very top of the very top line, we can actually add this keyword Go that I've highlighted in turquoise, and in front of any function execution, this would turn this method, getUp10, and it will add concurrency to the execution of this method. Funny thing, this reference actually is a reference to a rap song. Like I said, I like classical music, but sometimes I like to use references to rap songs in my code. The line goes, knock me out 9 times, I'll get up 10. So the interesting part about if we were to run this piece of code, and you have to trust me, and I hope you will actually prove it for yourself afterwards, we will get nothing. This function, even though we're trying to print on line 3, get up 10 times, this code will return nothing. And that's because after the call, go get up 10, so the only call that I'm doing in the main, the control returns immediately to the next line of code without waiting for the Goroutine to finish. So there are 10 of them. I start them off, I fire them off, but never wait for them to actually complete. And then the main Goroutine terminates, the func main terminates, and there is no other to execute. Hence, this method that I ran never actually get a chance to run. And then if we do want it to run, there are multiple ways for us to do it. One way for us to do it actually is to use a sleep function. Here I will, just like in the previous example, the difference is only that I'm adding this time sleep. I will start the Goroutine, I'll wait 4 seconds, and then I will print the final line afterwards. And the reason we will get, you can actually see in the next clip what the result is. But the cool thing is that once we call the go get up 10, there is enough time to actually execute all those routines within those 4 seconds and print the main function. So let me show you actually. This is my first time trying to run it for you. So let's see if we could run this clip. Running into my favorite terminal. So as you see, like they get printed 9, and then now we will get the main output from the main function. Now let's talk also briefly about, I hope, hang on, don't want it to go in loops. I want to talk about channels. And channels is also a cool Golang mechanism to communicate within Goroutines. You can think of them as bridges that can send parameters to different Goroutines. Channels can do 3 things. They can send, they can receive, and they can close. When data is sent to a channel, the control is blocked in the send statement until some other Goroutine reads from that channel. And that's a very important concept that actually eliminates a lot of danger that we previously talked about related to multithreading. And similarly, when data is read from a channel, the read is blocked until some Goroutine writes to that channel. By design, channels prevent rest conditions. When trying to access shared memory using Goroutines. And this is the property that actually helps them communicate effectively without the use of explicit locks or conditional variables that we're maybe familiar with other languages. For example, I'm familiar with Java. And just to highlight this point again, there's no storage capacity in channels. They're just mechanisms, they're just means to send or write information. And the message must flow from the sender to receiver immediately. They cannot store anything in them. And if there's no receiver, then the message is stuck with the sender. And the data available inside the Go channel is accessible to a single Goroutine. So there is a one-to-one relationship between the sender and receiver of the data. And if we were to briefly look at the code of what it looks like, here on the very top line, I'm making a channel of type int, and that's a pretty important important highlight in terms of types as they're going to come in later. In the second line, we're reading data from a channel. So the arrow shows the direction of the data that it's going. And the line above, we're actually writing to data. And then at the very end, we're closing out a channel. I just want to say one important part that channels can be actually buffered. And by being buffered, that means that they have a specific size of information they can hold. In this example, and examples to follow, I'm actually using unbuffered channels. If we buffer them, we have a more flexibility, more control over how we synchronize them. But for now, you don't have to worry for this presentation. It's a very cool thing though. So here comes the dangerous part. There's one thing that can happen when we're using channels, and this is the deadlock. Since Goroutines have their own mechanism of managing memory access, channels actually is a thing where things can go wrong. If, for example, we imagine a case, like I said, if Goroutine is sending data on one channel, that is expected that some other Goroutine will be receiving this data. And if this doesn't happen, then we end up with a runtime and a panic. Or we end up with a panic at a runtime and a deadlock. And just like in a similar fashion, right? If something is receiving a data, and then some other Goroutine is expected to write data on the channel, and if it's not happening, then the deadlock will panic. And of course, I want to show you what that looks like. So if in the program above, we have this channel ch that's created, and we send just an integer 10 to that channel. In this program, no other Goroutine is receiving this data, right? Because the data is only flowing to the channel. And because of this, we will get this fatal error that all routines are asleep, which is not exactly, I mean, partially some of them are asleep, but what's actually happening is that sends and receives are blocking by default. And this means that once the data is sent to a channel, the control is blocked in the send statement until something reads from that channel. So the way we could resolve this, we could actually add a buffer, like I said, to hold this data, or we can, the easiest way for us to resolve this is to actually have a Goroutine receive this data from this channel. So I wanted to do like a very German reference example here, and use using the channel. It could be like a lot of code to read at once, but if we kind of maybe like start in the main, we're creating this channel called done. It will start a Goroutine called make money, and we will close it with this line of code done. This receives the data from this done channel that we created before, but it doesn't do anything with it, right? Like it's just a way for us to consume the data that we're sending from above. And that's a way for us to prevent this deadlock. And that's a way for us to actually print the line down below, which is 25 cents. So nothing is really blocking the sends, and our writes aren't blocked as well. And this way, the output of this function is first going to be upfront, and then we're actually going to get 25 cents right below. And now the highlight of the stack, hopefully, is how we're going to piece all those concepts together and use a pipeline. Because an idea of pipeline, it's a kind of concurrent program. There are honestly many of them, but pipeline is a way for us to orchestrate channels and Goroutines to, like I said previously, for example, process streams or batches of data. And that's how I use this. So think of a pipeline as a series of stages connected by channels. And a stage is sort of like not a term that is being used, but I would love for you to think of it as either a single Goroutine or a group of Goroutines running the same function. It's quite important that a stage consumes and returns the same type. So in the code before, I was showing you that we were having channels of type int, and it's quite important, as you can imagine, that whatever we're sending is whatever we're receiving, or the other way, right? Whatever we're receiving is of the same type. Otherwise, like our structure is not going to work. And just to put it into more simple terms, so imagine channels are sending values to a stage, which de facto are routine or Goroutines, and they're being received by other channels. There are three things that happen within Goroutines in each stage. They receive via inbound channel, they perform and they produce. They usually produce new values, but sometimes they can just like perform function on their data, modify it, and then they send it downstream. Each stage can actually have any number of inbound and outbound channels, except the first and last stages. Those can only have a single inbound and outbound channel, respectively. And you can think of the very first stage as a source of a producer, and the very last stage as a sink and a consumer. And I want to explain, like I said, this is a talk for beginners. I wrote much more complex code when I was using this and applying this concept, but hopefully you will be able to follow what I'm showing. And I also want to give credit to Samir, who wrote the blog post on pipeline almost 7 years ago. I checked this morning. And to give you an idea about what we're about to do, we will take a slice of integers, we will generate squares of those slices, and we will return it. So like I said, the first thing we're going to do is just convert a list of integers to a channel and emit those integers in a list. So this function generate, it starts a Goroutine. And here's, I want to like briefly highlight that we're actually using an anonymous Goroutine. If you can see like Go, Func, in turquoise, that also has just open brackets and nothing in the round brackets. That's an anonymous Goroutine that will turn that list that we got as an input and return as a channel. And the really important part here, again, is that we're actually going to be closing that channel when all the values have been sent. So, we kind of don't end up with a deadlock of sending things out in the wild. We will actually manage this ourselves. And then the second part is the stage. So this is where we're actually going to be receiving integers from a channel and returning a channel that emits squares of them. So again, we're kind of using the same concept of anonymous Goroutine that I didn't highlight in here, but hopefully you can see it in the middle. What it does, it goes through the values that we have in a channel, and then it generates squares. So, just multiplies them by themselves and sends them to this out channel. And the inbound channel is closed at this stage. And we've sent all the values downstream. And now we're also closing this outbound channel as well. So we're returning it at the very end. Now let's put it together. So in the very first two lines, we're actually setting up the pipeline. So we're using that function that we're going to send two numbers. We're going to send 2 and 3. And then the second line is our stage. So out is going to be a channel of our squares. So this main function will also be consuming output as long as there are numbers, and there will be 2 values. And it runs this final stage, right? So it receives values from the channel, the outbound channel, and it prints them until it's closed. So the output of this code would be 4 and 9, which is the square of 2 and 3. And the one cool part that I want to highlight in invite you to explore it on your own, is the fact that you can actually make it cooler. You can nest or you can fold those pipelines. So remember, like I said, we can have however many stages we want. It's just a matter of us sequencing and managing and arranging in such a way that, we always have the same types, and each stage performs a single function at a time. So I wanted to show you using that example. Again, don't want to overwhelm you, but since we have the same type for inbound and outbound channels, we can actually compose it however many times we want. And we actually, if we're diligent about it, we can also compose them in different fashion, which is why this method lends itself very well to batch processing, doing very similar types of steps or functions on data, because we can run them as fast as we want to concurrently by using pipelines. So what we're doing here is in the loop, we will be actually generating squares of squares that I showed you before. And I'm doing a little bit of a different output here, but while we're generating that output, we will actually get 16 and 18, which is a square of 4, which is 2 to the power of 4. And we're going to get 18, which is 3 squared squared, which is 3 to the power of 4. This, I would want to say, like, the magic of pipelines, something that I found really exciting. Definitely, I think an awesome topic for another talk that hopefully I'll give on error handling and what can go wrong if actually something, I think especially when dealing with real data, when we get errors when processing, and how do we handle those. And for that, I actually have a slide for the nerds in the front. Here are some resources that I used, and I think, I think the pipeline link is where, if you're curious, you can read more about it. There are also different use cases or sort of like different approaches to going further with pipelines. And I highly recommend the Rob Bikes talk, Concurrencies, Not Parallelism. If you also, just like me, are a beginner to Go, or just curious about how and why concurrency was designed in going a certain way. And at this point, actually, I just want to say a huge thank you to everybody for tuning in on a Sunday. Thank you, Daph Fazdak, so much for having me. This is my first international talk, which is super special. I hope you learned something. Please definitely stay in touch. Let me know if you have any questions in general. I write a Medium, and I hope to be writing more by Go. But I'd be happy to take any questions that you may have. Hey, Evgeny, I think you're muted. Or maybe it's my...
You're right. So thank you for fixing this. I think this is such a nice talk. Bravo, bravo, bravo. Brilliant talk. I think this is the nice step to introduction in love with language. And I think it's a best step. Just watch a recording or talk to you directly and ask for the introduction steps. I'm also love in Golang, and I'm happy to learn some things. And this is nerd slide was super nice.
I'm glad there are more than one nerd on this call. It makes me very happy.
Good, thank you so much again. So we have this Q&A session. If we have such questions right now in any type, please just type in Twitter or just write an email for us. We will directly show these questions directly to Anna, or if you have the join our stream, just ask the question in the chat. So we will have some minutes to wait for the questions. Yep. I know that typing questions is hard sometimes, so just wait for another minute or such a way. We could also check the Twitter line. Here we have the also tweets from the first track, I just want to remind that we have two tracks, and you can go to the Dev Fest online. This is our website where you can check and read more about the speakers that we have today.
Thanks, Patty.
We have a great feedback from the listeners. Okay. 1 more minute to type or check for the questions. And I will check the timeline for Sunday. That's a big fun day for us. And we will have the next speaker in, I guess, 10 minutes. Less than 10. Yeah, checking for the questions. There is no.
Welcome.
But such amazing support. Thank you, audience.
I think the part that I like about Going community, and it's too bad I never got to, while I was still in Berlin, I never got to go to any meetups, but in New York, it's a very welcoming, it's a very warm community. So if any of you are traveling, definitely be in touch. Had a great time. Just as I think as a beginner a year ago, meeting people who love Go. And I think that's the most beautiful part about language, just because it's so warming and welcoming.
Yeah, so true. So here also, before lockdown times, there was so many meetups and so many events, like a hackathon, so small. And there was also the group of travelers who go around Germany or Austria and join the talks. And now we are online, so we can do this from the chair or from the garage like I do, but not so many things happening offline.
Yeah. Oh, but I think our love for Golang transcends continents.
Yeah,
So
true,
I
true,
think that's. I actually have my Golang pin. Yeah, I wanted to wear it today, but it's just like so
true.
early.
All right.
So this is the pin that I got at the first meetup. So I keep it on my desk.
Nice. I see so that there is not so many questions right now, but if there is any, we will come back to you and ask for answering them.
For sure. Yeah, feel free to
Thank you
tweet
again.
me. Yes, my
Yeah.
pleasure. Thanks for having me.
Thank you. Ciao, ciao.
Bye.